Okay, this is the P4 paper from June 2023. It's question number 5, and as we can see, this is an integration question. We've got integration by parts for the first one, and then integration by substitution for the second one. Let's get going with the integration by parts. So part 1, we're going to have to integrate x squared e to the x dx. And what I tell my stronger students is when we're looking at this, just have a quick look at it before you get going. And hopefully, if you've done a lot of practice of integration by parts, you can see that when I go through the process, what will happen is this x squared will come down to x e to the x, and then I'll have to do it a second time to get it just to be e to the x, and then we can get going and doing it. So I'm aware of that before I get started, that I'm going to need to basically go through the process twice. So let's get on with it because it's going to take us a bit of time. So we say u is equal to x squared, which gives me du by dx being 2x, and we say dv by dx then is equal to e to the x, and when you integrate that, e to the x just stays as e to the x. So that should help us when we're trying to do our integration by parts. The integration by parts formula, I always make my students write it down. U dv by dx is equal to uv minus the integral of v du by dx, and then just substituting everything in, then we're going to get uv are those two, so I'll get x squared e to the x. I'm not too worried about that anyway. It's this next part has this simplified as an integral, and it has, this comes to be 2x e to the x dx. So if we compare this one with this one, we can see it's got simpler. It's gone from a quadratic just to a 2x here. And if I now go through the process again, and I'm going to do it really slowly and explain what I'm doing. So I'm now going to say, right, I'm just focusing on this part here. So I'm actually going to do, what's the integral of 2x e to the x dx? Well, again, if I'm doing that then, set u to be 2x this time, and du by dx will be 2. Leave my dv by dx as being e to the x, which again is going to give me v equals e to the x. You can see I practice a lot of these, so I'm going through all of this quite quickly. So we can now say the integral of u dv dx is equal to uv minus integral of v du. I write it down just so that it means I remember the formula. The more often I write it down, the more likely I'm going to remember it. I'll need to be able to have it coming just really, really quickly when I'm looking at it. So uv this time is going to be 2x e to the x. Excuse me, sorry, 2x e to the x minus, but now this time when I'm doing it with my v du, with my v du here, I'm going to get minus 2e to the x dx, and I can now integrate that. That's in a format where I can integrate it. So tidying that bit up is 2x e to the x. The integral of 2e to the x is 2e to the x plus my constant here. So what I've done, that part there is that part there, and I know that my actual answer is going to be x squared e to the x minus this part here. So just making sure you're being careful with doing this, which, as I say, if you've done a little bit of practice, shouldn't be any problem at all to you. So let's say the whole thing, the integral of x squared e to the x dx was equal to my x squared e to the x up here minus the integral of all of this stuff. So minus everything I've got in that bottom but one line there. So minus 2x e to the x, but minus makes plus 2e to the x, and the c, we don't worry about that, that stays as our constant there. So, yep, that's the first part done. No, they didn't give me anything, so they're expecting me to be able to do that. They didn't show it's equal to something. Absolutely fine. And now this second part, I've got an integration by substitution. So again, talking about my students and how I explain it to them, I say that whenever I've got a substitution, the key, and it does work with this one actually, the key is always getting this dx part. When I get the dx part first, it may well be, as it is with this one, that that I don't need to worry too much about that one there. You'll only find out by doing it, but I've already done this question once before. So whether I'd done it or not, I would always say to my students, when you get u, what we've got to do is we've got to substitute that, and substitute that. Now the dx is definitely substituting in. One of the other two, we might be able to work out just by what happens when I do my differentiation. Let me explain that by doing the question. It might make a little bit more sense when I've done that. So let's have a look at this part 2 then. So we've got, what was it? The integral of 27x. Okay, so the integral of 27x all over square roots of 1 minus 3x dx, and they've said your substitution is u equals 1 minus 3x square root. So as I said, I'm going to focus on dx first of all, or in other words, differentiating or getting du by dx. Before I do that, let's just make sure that's something that looks like it can be differentiated. So let's write that as to the power of a half there. Now I can differentiate this, du by dx. This should not cause you a problem if you're doing P4 papers at this stage. We treat it as though it's something to the power of a half. So differentiating something to the power of a half is half the something to the minus a half, multiplied by the power, take one off the power, and then with these function of a function questions, times by the differential of what's in here, times by the differential of 1 minus 3x, which is minus 3. Right, let's tidy that up. That's minus 3 over 2, 1 minus 3x to the minus half here. Now that's du by dx, and what I actually want is to get dx equals, because I'm going to sub it over. So yeah, just be careful of this. Well, do it slowly. It's du over minus 3 over 2, 1 minus 3x to the minus a half. That's equal to dx. I just took that up there and took the other one down there. But now look, this left-hand side can be tidied up. I don't want to have it written down like that. What I'd much rather say is that if you're dividing by minus 3 over 2, that's the same as timesing by minus 2/3. And 1 over 1 minus 3x to the minus a half is 1 minus 3x to the half. And then my du is equal to dx. So basically, because that was divided by, you can sort of flip it up there. But just have a look at what I've done there. Hopefully that makes sense to you as we're looking at it. So there's my dx bit done. Okay, so when I've got my dx bit done, look what I've got in here. 1 minus 3x to the half and a 1 minus 3x to the half. They are going to cancel each other out in a second. Okay, so now I just focus on changing the 27x. So that bit I do have to do. So let's go back and remind ourselves. Substitution was square root of 1 minus 3x. I need to get 27x. So if I need to get 27x, let's do square both sides. And then I can rearrange to get 3x equals. So 3x is 1 minus u squared. And then 27x multiplying by 9 here, 27x is equal to 9 lots of 1 minus u squared. So if I go back to what I'm trying to do here, then what I'm trying to substitute in, I'm going to substitute that one. I'll put the dx in, and then I'll leave the root 1 minus 3x, and you'll see what's going to happen here. And as I said to you right at the start, I sort of knew something like this was going to happen as we were going through and doing this. So just to explain it to the examiner, hopefully nice and clear. Oops, not with that pen. We had 27x all over square root 1 minus 3x dx, and what I'm saying now is that's the integral of, well, 27x is 9 1 minus u squared, but then just the dx part is here. So if I put the dx part in, I get minus 2/3 1 minus 3x to the half du. So I'm going to leave that part just as it is already and have that there as over square root of 1 minus 3x, because then magically that and that are going to cancel each other out. So it's not an unusual thing to do. That shouldn't surprise you too much. That can happen. So that's why it's always important to get the dx bit in and just see what happens here. Right, so let's just focus on getting that all tidied up then. That's now the integral of, you've got 9 times minus 2/3, that's minus 6. And then we've just got 1 minus u squared du, and everything else just disappears there. Okay, so if we're doing that then, we just need to tidy this all up now. So that's, I've got space there, yeah. That's the integral of minus 6 plus 6u squared du. So the integrating part of this now is really easy. Add 1 power, divide by the new power. I'm going to get minus 6u. I'm going to get plus 6u cubed over 3 plus my constant. And now remember, we can just substitute back in what we've got. We know that, what was u? U is 1 minus 3x to the half. So we're actually going to have equals minus 6. I'm just deciding whether to put 1 minus, no, I will do, I put 1 minus 3x to the half. I was deciding whether to call it square root, but we won't do yet. So it's minus 6 lots of that, plus 2u cubed, which is 2, 1 minus 3x to the half, cubed. Now, if you want to, you can put cubed like that, but I'm not going to do that. I'm actually going to say, if it's a half, cubed just becomes 3 over 2 there, plus a constant. If you're not sure about that, then just do a bit of work on actually working with your indices. Now, what we're trying to get it to look like. Right, okay, and then, yeah, a little bit of work here involved in just getting it to look like this thing, which looks to me like they've taken 1 minus 3x to the half out as a factor, and minus 2, but let's see what happens if we do that then. I can probably get there pretty much straight away here. So I've got, what have I got? I've got, yeah, 2. That's 3 over 2, isn't it? Yeah, so I'm just being careful here. I've got 2, 1 minus 3x to the 3 over 2 minus 6 lots of 1 minus 3x to the half plus my constant. Don't worry about the constant. The constant is just plus c all the way through because the constant can just keep changing here. So if I'm looking at this, if I did take 2 and 1 minus 3x to the half out, what would I end up with? So if I took that out, taking that out of that first term, I'm going to end up with 1 minus 3x, excuse me, and then taking it out of the second term, if I've taken the 2 and the 1 minus 3x to the half, I'll just be left with minus 3 here, plus my constant, so that's 2, 1 minus 3x to the half, and then 1 minus 3x minus 3 is minus 2 minus 3x plus c. And if you go back and look at the answer, all they've done now is they don't want that to be minus 2 minus 3x, so they've taken the minus out the front, minus 2, then I've got 1 minus 3x to the half, 2 plus 3x, or 3x plus 2, doesn't make any difference, 3x plus 2 there, plus c, and then that's actually in the correct format as to what we wanted there. So, yeah, really good question. Absolutely just checking out standard integration by parts, even though we've got to do it twice. And here, as I said at the very start of the question, hopefully it makes more sense now we're talking about it, that becomes the key, getting rid of that. When I get rid of that, actually I didn't need to substitute out for that one, but I did need to substitute out for that one. So you might need to look at that video a couple of times, but hopefully that all makes sense.